Welcome to MEI Numerical Methods Convergence. In this video we'll be continuing with numerical differentiation. Now, in the same way as for numerical integration, we can use the ratio of differences to do some extrapolation and find an improved estimate for our derivative. So if CDH represents the estimate with a width of h, and then the next estimate would be CDH over 2, where we're halving the width, and so on, then the ratio of differences is the k that appears in the formula that we were looking at in the last video. So k is the ratio of the absolute errors, and that can be arranged as shown there. And again, to give us an expression for CDH over 4 in terms of CDH and CDH over 2. So as for the midpoint and trapezium methods, we come up with a geometric series which we can take the sum to infinity of, and the common ratio is once again going to be a quarter for the central difference method, and so that gives us a figure of a third in the final formula, and that's the extrapolated estimate based on CDH and CDH over 2. But if we had CDH over 4 available, it would be better to use CDH over 2 and CDH over 4. And the approach is exactly the same for the forward difference method, except that we've got a common ratio of a half instead of a quarter there, and that gives this expression for our extrapolated estimate based on FDH and FDH over 2. And once again, if we've got some later estimates, then it's better to use those instead. So that concludes the videos on convergence.